We're going to do some practice with multiplying fractions using models. So the first problem we're going to do is 1/6 times 3/4. So the way we're going to set this up is we're going to draw a large rectangle. And the way I tell my kids to do this is take either one of your fractions. We always like to start with the first one. And our denominator is going to be the one that tells us how many times we're going to split up our box. And we like to start vertically. You can start using rows, it doesn't really matter. But so this denominator is going to tell us how many times we're going to split up our box. So once I draw my first line, I've split it up twice. That makes 3 times, 4 times, so I have 1, 2, 3, 4. 1, 2, 3, 4, 5. I'm going to just make one more this way so they look a little bit more even. 6 times. So our fraction here, 1/6, says I need to shade in one of those 6 columns. So right here, this shows me this is 1/6. So on the other side, I'm going to separate it 4 times. There's 2 of them. There are 3. And now there are 4. 1, 2, 3, 4. And I need to shade in 3 of them. So this is showing 3 out of 4. So I'm going to shade them all the way across. So right here, I've just shaded in 1/4. Now I have 2/4 shaded in. Now I have 3/4 shaded in. So if I'm going to be looking for the product of 1/6 times 3/4, I'm looking for the boxes that have both colors. So here's 1, 2, 3. That's my numerator. And then how many total boxes or how many total parts are in my model? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And this goes right along with our standard algorithm for multiplying fractions. 1 times 3 is 3. 6 times 4 is 24. Let's go ahead and do another one. Let's do 2/5 times 1/3. So I'm going to draw my box again. The 5 in our denominator spot tells me how many times I'm going to split it going vertically. So here's 1, 2, 3, 4, 5. 2/5 says I'm going to shade in 2 of these. So here's 1, 2, 3, 4, 5. My kids found that this is a little bit helpful for them. So I'm going to shade in 2 of those. There's 1/5. And now we have 2/5 shaded. We have to shade them all the way down. So now we're going to do our next fraction, 1/3. That means going across all the way, I have to split it up 3 times. Our denominator tells us how many times we're doing that. So there's 1, 2, 3. So I'm using my pencil sometimes to show. Here's 1, 2, 3. And sometimes I like to write it down like this. And we're only shading in 1. That's what our numerator tells us. So I'm going to come all the way across. So I'm not just shading it like this, but we're coming all the way across because it's the entire 1/3. So that entire 1 out of 3 has to be shaded. So to find our product of 2/5 times 1/3, we're looking for what has both colors. So here's that one and this one. So that makes 2 out of how many total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let's look at that standard algorithm. 2 times 1 is 2. 5 times 3 is 15. And so our model represents that. So sometimes we're given a problem like this where we have the model and we're trying to come up with the problem and the product. So my kids have gotten confused because they don't really know where to start, and my answer is you can kind of start anywhere. You can start here vertically, or you can start with the rows. My suggestion is if you are used to starting vertically, then that's where you need to continue to start. So I'm going to also suggest, let's go ahead and find out the denominator. The denominator is how many times it is separated. So let's look here. 1, 2, 3. So our denominator is 3. How many of those 3 are colored in? I see 1, 2. Our third one is not colored in, so our numerator is 2. So 2 out of our 3 are colored in. Let's look over here at our second fraction. So I have 1, 2, 3, 4 is going to be our denominator. 1, 2, 3, 4. How many of those 4 are colored in? I see 1, 2. These 2 right here. So now let's look and see how many total boxes do you see? That's going to be our denominator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then of those 12, how many have both colors that are shaded in? 1, 2, 3, 4. Now we can check on this and see our standard algorithm. 2 times 2 is 4, 3 times 4 is 12, and that checks out.